Number one, all right, we're going to go ahead and record this. Number one is asking, it says, define delta H of the RXN. Oh my God. What the heck is RXN?
Reaction.
Reaction. Okay, good. So could anybody tell me how they define that? Did anybody define it?
The change of heat in the reaction.
All right. Okay. Very good. Delta H of the reaction is the change. Let's use our big word. The change. How do we define heat? What do we call it in chemistry? Enthalpy is the change in enthalpy. All right, for the reaction. All right, so this is number one. All right, or it could be the heat evolved or absorbed in a reaction. Or, what does evolved mean?
Given off.
All right, given off or absorbed in a reaction at constant pressure. At a constant pressure. Okay? So you should have all of that. And guess what? You get to read about that and outline that tonight. All right, number two says define specific heat. All right, so who has something for me about specific heat? Let's change colors. Change colors. Spencer.
The amount of energy it takes to heat 1 gram of a substance by 1 degree Celsius.
All right. Amount of heat required to raise 1 gram of a substance 1 degree Celsius. Okay? 1 gram of a substance, 1 degree Celsius. All right, with that being said, does anybody know any specific heats? Any values?
Like water is 4.184 grams.
All right, so the C of water, C is defined as specific heat. All right, so I'd say C of water is 4.184. What are your units?
Grams per joule. Gram per joules per gram.
What?
Joules per gram Celsius.
All right. Joules per gram degree Celsius. Joules per gram degree Celsius. And guess what happens if you're solving for grams? What do you think would happen to all the other units? They cancel out. You'd be left with grams. All right, if you're solving for energy, you'd be left with, if you're solving for temperature, you'd be left with, okay. Number 3. All right, once I get done with the pre-lab questions, you'll have a little bit of a break for processing time, let my video catch up. All right, I can't write this whole thing down, but we're going to write down the specifics. The specific heat of a solution is 4.18 joules per gram degree Celsius. All right, so we're going to say C of the solution. So if you were writing this problem and doing this problem on the AP exam or my exam, you'd write C of the solution is 4.1 joules per gram degree Celsius. You can put a times in there if you want. And its density is, I'll put density, that's fine. Density of solution, 1.02 grams per milliliter. Now I'm going to need your help with the calculators, so just have those ready. All right, the solution is formed by combining 25 mils of solution A with 25 mils of solution B. Let's go ahead and list that out, just so we know what we're doing. 25.0 milliliters, solution B, 25.0 milliliters. Okay, so we have that. With each solution initially at 21.4 degrees. So I'm going to say T equals 21.4 degrees Celsius, and I'll put both. I'm going to say T initial. Just so I know, T initial. All right, slow me down if you need to stop me. I'm just looking at it, deciphering what it says, so I can solve it in a minute. The final temperature of the combined solutions is 25.3 degrees Celsius. So temperature final, TF final, TF would be T final. I'll write final for now, is 25.3 degrees Celsius. All right, so it'd be TI and TF. Does anybody know what delta T equals? Well, no, just the actual equation. TF minus TI. All right? So delta T is always final minus initial. All right? Calculate the heat of the reaction Q, assuming no heat is lost to the calorimeter. I don't know why it says colorimeter. Use correct significant digits. All right, so we have this. All right, so what we need to know is we're going to calculate the Q. I'm going to go ahead and change colors, what we're going to be thinking about. The Q of the solution equals what? That would be solving for. Now, is the solution gaining heat or losing heat? All right, so we know right here that the solution is gaining, solution gaining. And whenever we have something that gains, how do we represent it? Positive or negative? Positive. All right, so this is technically a positive Q of solution. All right, you don't need to put that, but maybe it will help you understand. And what happens to the reaction? What is the reaction going to do? If the solution is gaining heat, what does the reaction have to do? What? Has to, one gains, one loses, right? So one gains, one loses. So we would have negative Q of the reaction. So one is gaining, the solution is gaining, the reactions are giving off heat to contribute to the gaining. That's why we give it a negative sign. We give it a negative sign because they have to give off heat in order for the other one to absorb it in. Yes? Yes? Oh, thank you. One affirmation. Thank you. Thank you. A couple of questions, you actually killed it on the test, by the way. I wish you did the whole thing like that. Some of them were just like ridiculous, but you know, get the rest. All right. Now, so when we have to solve this, all right, we're going to have, I'm going to go ahead and take this. I'm going to move it to the next slide. You have all this information. I'm going to put it up here. So I have my Q of solution. Now I'm going to need your help. Equals, and what would we say that it equals? MC delta T. All right, MC delta T. So let me break that down. Let me break that down. So we're going to do grams of solution. Ooh, that's interesting. Wait a minute. Let's put a little squiggly on that. Grams of solution times, what's next? What is it? specific heat. And that is, where do we get that? All right, given. So I'll put that here, given. And then, I know I ran out of space, times what? All right, delta T, which we know, break it down one more time so we don't forget it, is going to be TF minus TI. Isn't there a wrapper TI or something? TI? Yeah. I know it, I know. All right, so we're going to multiply all that together. All right, so can anybody tell me now the grams of solution? But we know, wait a minute, what else do we know right now? What do I need to add to this? Let me get my little pinwheel up. What else do I need over here? Over here? What did I just go through? I said heat gained is heat lost.
Hello, thermodynamics. Please sit down your attendance.
Yes. What is it?
Negative.
What is it?
The whole answer is
All right, so I'm going to put a negative here so you don't forget it. Negative there. Now, what happens if my final temperature was less than my initial? What would the answer become? Oh, you guys. You guys. All right, now we have this question mark sitting here. Grams of solution. Yes.
Since you have the density, you can do density equals absolute volume.
All right. So we have to somehow yank out using the density. So grams of solution, we had how many mils?
50.
All right, so remember that this was 25 mils plus 25 mils. We're going to take that and then we're going to do what? Times 1.02 grams per milliliter. All right, so that is this part right here. All right, so I added those up, and I'm sorry that keeps doing that. That's really annoying. All right, and then I have times. I'm going to go ahead and do this. 4.18 grams per joules per gram degrees Celsius. And my delta T, what's my delta T going to be?
3.9.
Oh, well, I have to write it out because I'm not that good. 25 minus 21.4 degrees Celsius. Okay, there we go. All right, what is that? And okay, what's my answer going to be? What? I can only do that. I don't have the. I don't have my calculator. I can only get you that far.
51 grams.
What is it?
51.
What's the answer?
The total answer?
Answer.
31.
All right, negative 800. I'm going to do sig digs joules. So Q of reaction, RXN, is negative 830. Who had that the other day? Pat yourself on the back. Turn up your shoulders, kick back. Right? Miss that? Miss that? Ah, gosh. I was so excited. I thought that was good. All right, question 4. In question 3, above, the calorimeter has a heat capacity of 8.20 joules per degree Celsius. If a correction is included for the heat absorbed by the calorimeter, what is the heat of reaction Q? So, number 4, so we have Q of reaction again. And that's going to equal, at this point, what? Now again, Q of reaction means that this side is what? This side? We're adjusting it. This side is positive. We're making an adjustment. So then this side has to be negative. All right, negative. And what are we going to say? Q of the Yeah, we're gonna have that. What's the other one?
Reaction.
Q of the calorimeter plus Q of the solution. All right, so we're going to have Q of the reaction plus Q of the solution. That looks right to me. All right, so let's plug this in. I'll go ahead and put this here. I'm going to put my negative back here. Don't want to forget that guy. And what am I going to have now for Q of the calorimeter? What is it?
8.2.
8.20 joules per degree Celsius. Then what?
Times the change in temperature.
Times the change in temperature. So,
3.9.
all right, so times, all right, we have a question out there in the crowd. 25.3 minus 21.4. Melissa? Question? Why would we put in here 8.2 and the change in temperature? What do we have here? Yes, Michael. All right, so we have the joules here. We're trying to find out the heat. We have to get rid of, let's think about it mathematically. We have to get rid of the degree Celsius. That might be the easiest explanation for you. All right, and from there we're going to do what? We're going to add Q of the solution, which we just solved. What's that going to be? It's not negative 830. What is the heat of the solution? 830. 830 joules. All right. Close that. And we of course remember Q of the reaction equals negative equals, okay, go ahead and tell me what you get here. What would I have for this part right here? All right, so 32, negative 32 minus what? 830 equals, because I'm distributing this, right? To that, sorry. Distributing that, and what do I get? Yes? It's heat of it's the whole kit and caboodle here. So this is of the solution, right? Remember, the solution gained 830. When we solved at the beginning, the reaction lost. We solved for Q of the reaction in the first one. QRXN was negative because they were losing heat, giving it to the solution, making it a positive number. You're good? All right, what do I get? Negative. Bueller? 800, I'm going to go 62 joules. So Q of the reaction. Now, does that make sense? Is the reaction again a negative number? Yes, because it's giving heat to the solution. So it's giving heat to the solution. It's again as a negative number. All we did was adjust it based on the calorimeter. All right, so it's going to give off a little more heat than it would have if it was just out in the outside atmosphere. Yep, that's what the question is saying. All right, and then let me do question 5. All right, you need a second on that? Second? All right, what I'll do is let me pause for station identification. I'll save that one. That was a good one. It's a good one. That was a good one.